Hello and good afternoon friends, welcome to the CEC-UGC live lecture. Dear friends, today we would be talking on IP addressing and subnetting, and for this very discussion we have once again with us in our studios Dr. D.K. Lobial. Dr. D.K. Lobial is professor in JNU. So let's welcome our guest Dr. D.K. Lobial and let's try to understand IP addressing and subnetting. Hello sir, welcome to this lecture.
Thank you very much. Now today we talk about the various IP addressing schemes and why do you go for subnetting. That is the today's lesson is, and let us begin with what is IP addressing and what are the different classes and how they are classified into different groups, and then what is subnetting and why do we need subnetting. That is what the whole discussion is today all about. Now what is IP address? If you look at it, is we also talked in the previous lecture, so it is a unique identifier for a computer or a device on a TCP IP network to identify it, and it is a 32-bit binary number usually represented in 4 decimal numbers separated by a period dot into octets. For example, if you look at 206.40.185.73 is an IP address. Each one of the decimal number is represented by 8 bits. So 206, 8 bit, 40 is 8 bit, 185 8 bit and 73, then it becomes 32 bits. Now, and which has a binary representation will be a sequence of ones and zeros, right. Now each address is a 32-bit wide, as I said, and the valid addresses can range from 0.0.0.0 to 255.255.255.255, because if all bits are 1, 8 bits are 1, the value is 255. The 4 octets, if every octet has 111, so it is 255.255.255.255. If all bits are 0, the value is 0, decimal value is 0. So every octet 8 bits, a 0.0.0, that means all bits are zeros in binary. That is what the sense is. Why it is like this? If you go like this, what you will find is, then there is theoretically, if you find out it is 2 raised to power 32, that is the number, it will be around 4.3 billion addresses are available if we use these 32 bits. But we cannot use all these 4.3 billion addresses, because this addressing scheme has a format. If you go by this format, what you see is that each address consists of 2 parts. One, what you call is the network address, and other is called host address. And some other systems may use more than one address scheme, like this is 32-bit. Some other networks may use, rather than 32-bit, it may be using 48 bits, larger numbers. So they may have a different scheme of representing addresses. So the IPX is a layer of for routing used in novel netware. Probably its address is of 6 octets, that is 48 bit, not 32-bit. Now, so these IP addresses of 32-bit are classified or divided into 5 classes. Now let us understand each one by one. Class A begins with 0. That means if you look at the first octet on the leftmost side, we put it 0, like 0 on the left hand side, it is 0 0 0 0 1 and then 2 0 1 1 1 all ones 126. Now what we are saying is it begins with 0 and it is one number. Now let me explain what does, and similarly we have a class B that begins with 1. If you look at the leftmost side, it begins with 1. So therefore it becomes, the first octet becomes 128, 1 followed by 7 zeros, it becomes 128, right. And the previous one, we say A, that is it 0 0 0 1, that means the first is the 1 value in decimal, and therefore it will be going up to 126, because in the class A, it's, you see it says 0 0 0 0 0 1 and in bracket we say 110, that means it is base 10, that is a decimal number. So it begins with decimal number 1 and hence it goes up to 0, 1, 1, 1, 1, that means first is 0, the remaining 7 bits are 1, that is 126 values and in decimal. Why not 127? Why this first bit is 0? That I will be explaining. Now, if you look at 2 class B, what we are saying, it begins with 1 0, that means the leftmost side is 1 then followed by 0. If you look at 1 then followed by 7 0, or I say 1 0 followed by 6 0, you can say, it comes to 128. That means the class A addresses begin with 1 to 126, class B address begins with 128 to 191, right, and similarly then class C begins and class C addresses begin with 110. So, that means when any address begins with 0 first bit, it is class A. If it begins with 10, it is class B. If it begins with 110, then it becomes class C. The 110 and the remaining bits are 0 amounts to or corresponds to a decimal number of 192. So, class C address in decimal numbers begin from 192, it goes up to 223 in decimal or in binary 110 and then followed by 5 ones, that is class C address. Now, look at this, why not 127 is there, it is missing. I said class A is from 1 to 126, then I begin with 128 to 191, 127 is missing there, and then class C I said 192 to 223. There is a continuity in B and C, but there is a discontinuity between A and B, that is 127 is missing. Why? Because this address is used or reserved for a very specific purpose. What is the specific purpose? That is 127.0.0.1. This is called a loopback address. That means, if you use this address, it is used to check the network whether the system is working as a host or not. That means, the network card in a system is working or not. So, that means, if in a system I send some data to an IP address 127.0.0.1 is the destination address. If I send some packet with this address, it will go to the same system, it will not go outside the system. That means, sender is the same system and receiver is the same system. That means, it is checking whether the same network device is able to send and able to receive, that is what is called loopback. So, this address will not be used by any public network. That means, to communicate with the internet, you cannot use the address beginning with 127, because it is a loopback address reserved for some specific purpose. Now, next is class D. I said class C is ending at 223, and to have the continuity, class D address begins at 224 in decimal and it goes up to 239 in decimal, and this is a special address reserved for multicasting. Multicasting means that if you send a message with this address as destination address, it will go to the multiple systems which will having the same address beginning with this number. So, one message broadcast means you broadcast to all the systems in a network. That means, if the computers in this room, they are connected to the same network, if a network sends a node or a system sends a message, if it is going to all the nodes here, that is called a broadcast. But rather than sending to all the nodes, I may identify certain groups. That means, if there are, say, assume there are 50 nodes here or 50 computers here, I will make, say, out of 50 I have a group of 20 only. It must go to this group of 20 only. That means, this group of 20 must use this multicast address, and I will send on this multicast address, only those 20 systems will receive it, that is called multicast. So, group D addresses beginning with 224 and ending at 239 are used for multicasting in a network, and they are reserved for multicast, right. Then we have another class is called class E addresses, and that begins with all ones, whereas D begins with triple ones 1 1 0 and E begins with 1 1 on. First 4 bits are 1. And now that means why we are saying 4 bits are 1 and first 3 bits are 1, then 0, then first 2 bits are 1, then 0, then 1 bit is 1 and then 0, so and so forth. With a specific region I will explain. But that means class E address begins from 240 in decimal to 254. Now why not 255? 1, and we did not use 0 as well, we started with 1 to 126. Please mind, we did not begin with 0 and we did not end at 255, we ended at 254. And this class E address is reserved for future use, it is not being used, and it is reserved for in future probably for some specific purpose. If you need to use some addresses, probably that group of addresses will be used. Now, why do you use, first let me explain, why do we say that class A address begins with the first bit at 0, class B with first bit at 1 0, first bit 1 and second bit 0, class C at 1 1 0, class D at 1 1 1 0, class E at all 1 1 1 4 bits are 1. So, there are 5 addresses, we need minimum 4 bits because 4 ones. So, now the reason is by looking at the bits probably you can identify the classes. Look at the first bit, if it is 1 it is not class A, at least you come to know. If it is 0 it is class A, if it is non-zero it is not class A. So, you have been able to, looking at the first bit, identified whether the address belongs to class A or it does not belong to class A. So, now once you have identified the first bit is 1, at least you have determined that it is not class A. That means there is a possibility that it is either class B or class C or class D or class E. Now, look at the second bit. If the first bit is 1, if the second bit is 0, it is class B. If it is non-zero, it is 1, it could be class C, class D or class E. Therefore, you go to check the third bit whether it is 0. If it is 0, it is going to be class C. If it is not 0, it can be D or E. Now, look at the next fourth bit. If it is 0, it is class D. If it is non-zero, class E. So, each bit by bit if you check, you can identify. So, every level of checking a bit, you are able to identify these addresses into 2 classes, whether A or non-A, then next bit B or non-B, A is already discarded, then next bit C or non-C, so and so forth. That is how you try to classify and identify the addresses. Now, and therefore, the class E addresses are not used for these addresses. Now, if you look at this, that means how these classes are identified. If you look at class A, what you find is the yellow color shows the network part and the green part shows the host address. That means in a network how many computers are connected. So, to have a class A address, the first 8 bits will represent a network and the remaining 24 bits will represent each host in the network. Say for example, in this room we have 50 computers and each computer will have a different IP address. That means the 24 bit value will be different for each of the 50 systems in this room if there are 50, but the first 8 bits will be common to all the computers here. That means if the first 8 bits are same for all computers, if it is a class A address, that we assume that these all nodes with the common first 8 bits belongs to the same segment of the network or the same network. And the remaining 24 bits will say, oh, this is address of a different computer than this. And similarly, in class B, the first 16 bits, 2 octets, are network bits and the remaining 16 bits are the host address or the individual computer's address in or on a network. So, that means similarly class C, that is how we have differentiated. So, the first 24 bits or 3 octets are representing a network and the remaining 8 bits are representing a host on a given network. Now, this way if you look at, the IP addresses, we will find that the class A, it begins from 1 to 26, and therefore, there are 126 different network possible 2 raised power 7, and the number of hosts is 2 raised power 24, that is 16 million. And keep one thing in mind, I said in the beginning, the class A address begins from 1 to 126. I missed 0, that I have not explained. I said 0 is not used, and then class E, I said it ends at 254. I did not use 255. So 0 and 255 are not used to address any of the hosts. Why it is so? 0 address as a host address will represent a computer system itself. That means, if you use an address, say 110.14.10.0, that means, what are you going to say is that I am using the 0 towards the end if it is class A, but let us see it's a 110.0.0.0, take it that way, because only 8 bits are class A network address, the remaining 24 bits are the host address, all 24 bits are 0, I am not going to use that. That means, it will represent the address of the same system where this address is given. So 0 address is used to represent a host itself. That is why it is not being used given to any particular host. And 255 is used to address all the nodes. It is a broadcast address. That means, if I send a message with 110.255.255.255, that means 110, this is class A address because it begins from 1 and ends at 126. So 110 is class A. That means, I am referring to a network whose address is 110 and it is a class A address, and the remaining portions of 24 bits are representing host on that network, and that all are 255.255.255. That means, when I send a message on this address that 110.255.255.255, this message will be delivered to all the nodes or all the computers connected to this network address 110. That is why it is called a broadcast address. So, in a given network, if I have to send some message to all the nodes, host address portion I will put 255. If I have to send a message to the same network, I will use the host portion 0, or I may be using loopback address 127.0.0.1, I said in the beginning. So, to send to the same network, we have two ways. One is loopback, that is only checking the network card, and then we have to send to the same host we are representing, it is the host portion will be 0. So, if you look at the number of networks you can use in class and the number of hosts, it said 126 in class A, and class B we have 16,000 hosts, because 2 raised power 14, because first 2 bits are used to identify the network, it is class B, and then therefore only we have remaining is 14 bits, 2 raised power 14 networks, that is almost 16K number of networks we will be representing by using class B addresses. And if you look at class C, we have first 3 bits, 110 is a class C address, and therefore first 3 bits are not used. So, out of 24 we are using only 21 bits, and therefore 2 raised power 21 networks are possible, that is 2 million almost. And therefore, the number of hosts, if you look at each classes, for class A, because the first 8 bit are network and remaining 24 bits are the host, the number of hosts possible are 2 raised to power 24 minus 2 basically, because 0 and 255 are not used. So, therefore, it is 2 raised to power 24 minus 2, almost 16 million. And similarly, for class B, we have 2 raised to power 16, because the 16 bits are used for host ID. So, it is almost 2 raised to power 16 minus 2, that is 64 kilo or 1000, 64,000 host. And similarly, for class C, we have 2 raised to power 8, because first 24 bits are used as the host at the network address, and only last 8 bits we are using as a host ID. So, therefore, we have to have 2 raised to the power 8 minus 2, that is 256 minus 2 we have only 254, that is not 255, it should be 254 because 0 and 255 is not used, it should be 254. So, now what we have seen from there is that a class A address if you use, we can have a fewer number of networks, whereas in each network we have a larger number of hosts. And in class B we have almost a moderate number of hosts as well as a moderate number of networks. In class C we have large number of networks, but only small number of hosts. And now if you look at all these, it is difficult to find an organization which will have a network with millions of hosts. So, therefore, and a network with only 254 hosts may be a small also, because most of the organization today will have more than 254 hosts. So, if you look at that way, the class C address given to a organization, assigned to an organization, may be a small one, because one network may not be sufficient, because 254 hosts on a network is a too small a number. Whereas class A is a big network, you give a class A address where one network can use almost 16 million hosts. I do not find, or you will not find any organization with 16 million hosts in its organization. Therefore, the rest of the addresses only few thousand hosts, then rest of the addresses are almost waste. So, class A address are resulting into waste, class C addresses are falling short. So, therefore, the class B also a waste as well as falling, what you call waste mostly. That is how the situation is. Now, these addresses, if you look at in binary form, could be represented as class A, class B, and class C, and class D, and class E, and with each bit given there can also be, and then the same has been represented in different form. Now, there are certain addresses which are not used as public IP addresses. That means you cannot use in the internet, right? What are those addresses? If you look at class A address, where you say 10.0.0.0 to 10.255.255.255, and similarly we have in class B 170.16.00 to 172.31.255.255, right? And then we have 192 in class C, which is 192.168.0.0 to 192.168.255.255. Now, this group of addresses in each class A and class B are called private addresses. That means any organization can use these addresses for its own internal purpose. That means using these addresses you cannot interact or communicate with the internet, but they can be used for communication in an intranet. Intranet is a network where organization can address each other. Each computer system within an organization can communicate with each other. So, these private addresses can be used by any organization, because you are not communicating outside. Therefore, the same address can be used in this organization CEC and can be used in some other organization like IIT and some other organization. The same address can be used in multiple places. There is a private addresses, but the IP addresses which are not private cannot be given to two organizations. So, one address like if 192.74.18 is given to some organization, or 210.52.16 is given to some organization, that cannot be given to other organization. The reason is otherwise there will be a conflict of addresses, because a packet coming from one network should have a unique source address as well as a unique destination address, so that there is no conflict or no difficulty of ambiguity to identify a proper network where the message has to be sent. So, why these private addresses are useful is sometimes we have limited public addresses, like say class C address. If you are given, we can have only 254 hosts. One class C address will only allow us to connect only 254 nodes or hosts or computers in a network in an organization. But the network may grow in an organization, it may have 1000 computers. So, I do not have 1000 addresses, I have only 254. How do I make all 1000 to interact with the internet? That means what I use private addresses, because I have enough number of private addresses. If you look at how many addresses from 10.0.0.0 to 10.255 or 255.255, large millions of addresses. So, what do I do? For my all computers internally, I will use private address. So, addressing 1000 computers in a network with these private addresses is not a big deal. But however, with these private addresses, I can communicate, each computer within the organization can communicate with each other, but how to communicate outside? Ultimately, these private addresses have to be mapped into a public address when I have to communicate outside. That means, I have taken a public class C address, say for example, that is 198.41.10 is my network address, which is class C address. So, using that 198.41.10, I have only 256, that is next is 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 255 hosts. Now, this private address has to be mapped into these addresses to communicate outside. That means, my router locally will have a mapping table which will map these private addresses to a specific IP address and then communicate the message outside. When the message is coming out from outside with the public address, it will map that public address to a private address and send the message to the right host. This is how the whole communication will take place. Now, when I do this, now the question comes, how does a router sends a packet to a right host? That is important. So, distinguishing which portion of the address is identified as a network and which portion of the address identifies the node. That means, while a router gets a packet, it will look into the destination address in the packet. If you remember, when we talk about IP datagrams, we talked about what is the packet header, and then a packet header contains a destination IP address and a source IP address. When a router receives a packet, it will look at the IP header. Within the IP header, it will look at the destination address and it will find some address like 192. something like that. Now, out of that address portion, it has to identify the network portion, and based on that network portion of the address, it will decide the path or the route where the message has to be disseminated or to be transmitted, so that it does not go in a wrong route. So, it goes on a right route, and with the smallest time it can reach the destination. It should not take large time to roam around, and then so the end-to-end delay is very important. So, therefore, and once it goes to a right network, that means when it goes to 198.41.10 network, then within that network, it is the responsibility of the network to deliver the message to the right host. So, the router task is only to deliver a message to the right network, and once a message delivered to the right network, and that network will take place of delivering the message to the right host. Like say for example, in this organization, all the computers are connected to a network and they will have a router which is communicating outside. So, if say for example, a message comes from Yahoo server to this some node in this network. So, if assume that the network address in this organization, if I am assuming, I do not know what the right address is, it say 198.41.10 is the address network address of this organization. So, any message packet coming from the Yahoo server will contain the destination IP address as 198.41.10. So, any router in between, when it looks at this address, it finds that 198.41.10 is network address, which is somewhere in India across here, then it will send to a router which send the message right to this organization. And when this message or packet comes to the router at this organization, that 190 router with 198.41.10, maybe the router address is .1. And now the router here in this organization has a task to deliver it to the right computer. It will broadcast and probably the right computer, or it knows where the address is, it will directly send, because it also resolves the MAC address of the machine on this network, because the address resolution protocol which we discussed in the earlier lecture is useful here, because 198.41.10 dot says 26, it has to go to 26 host, then this has to be resolved into the network or the interface card address, that is hardware address of that machine. So, router will contain a table in its cache and then it will be delivered to the right portion. So, how this is identified, this network portion, and this is we call masking. That is, if you look at class A address, it said the mask is 225.0.0, and for class B 225.225, that means the network portion is 225 in both. In the class A address 8 bits, so it is 25, class B first 16 bits, so 225.225, class C is first 3 octets, it is 225.225.225, that means all bits are 1, 225 means all bits are 1, and the remaining .00 portion represents my host address. Now, how does it happens is, if you do some AND process with this mask, that means the moment I said 198.41.10.26, say for example, if I do the operation AND operation with 255.255.255.0, what will happen is the first 3 octets, first 24 bits are 1, 1, 1, 1, 1, and remaining bit is 0. The fourth octet is 0. If I do its ending with 198.41.10.26, because 26 is ended with 0, therefore this becomes 0, and the remaining 198 is being ended with 255. So, it will give some value 198, because what is the value? All ones, 1 is and 1 and 1, if you AND it becomes 1, 1 and 0 becomes 0. So, therefore, whatever bits are 1 in 198, it will remain 1, whatever bits are 0 in 198, after ending process it will remain 0. So, it remains 198. So, is with the 41, second is 41, and then we are doing it 1, 1, 1. So, whatever bits are 1 in 41, it will remain 1, and whatever bits are 0 in 41, it remains 0. So, it remains, what I will get it 198.41.10, that is my network address. So, this masking is used to identify the network portion in a given IP address. But therefore, if you look at class A, B, C addresses, what you are finding is some difficulty is that class A address is too large, there is a waste. Class B addresses are also too large, there is a waste. Class C addresses are very small. So, what do? If we have to use class A, B, C addresses, we have to do subnetting. That means, within a network we will try to create a subnetwork, that is what the sense is. So, create multiple logical networks that exist within a single class A, B, C network. So, as you said, the first 8 bits in class A address are used for network, remaining 24 bits are used for host address. Now, the question is, can I use out of these 24 bits some bits for again to identify the network? So, I will call this subnetwork, a network within a network. Network address first 8 bit, out of 24 bits some bits are I am using to again address the network, and that is called subnetting. Why it is important? Because I can create multiple networks with the large address, and then I can have, why do I need multiple networks if I have large number of hosts? That I will answer next slide. And if you do not have a subnet, you will be only able to use one network from either A, B or C, which seems to be unrealistic, because class A address if I use, I cannot have millions of hosts, and class C address if I use, I have too small number of hosts. If I have 1000 hosts, if I use class C, I cannot have sufficient address. If I use class A, lot of addresses are being wasted. So how do I, and 1000, 4000, 10,000 hosts, then I can divide into sub networks and then divide these 10,000 hosts into 254, 254, 254 each one. So I may have around 4 into 10, I think 40 subnet. So each data link on a network must have a unique network ID, that is what we are assuming, and every node on that link being a member of the same network. What does it mean? Let me explain it. Now look at what are the benefits of this subnetting. Why do we go for subnetting? Now reduced network traffic is important. Why I am saying this reduced network traffic is, assume that if you have a large, if I use class A address and if you have used 10,000 hosts as part of one network, when you broadcast it goes to 10,000 networks, 10,000 hosts on the same network, and broadcasting on 10,000 hosts may result either into collisions or may increase the network load and the traffic. And when the router has to send, and if from a router, if the message comes through single segment and going to a large number of hosts, then the network becomes slow, because my bandwidth will be limited and I am sending to large number of, so more data is going. One. So therefore, if I divide in the sub network, it will be much useful, because I will be sending broadcasting only to a small portion of the network, so it will consume a small bandwidth. One, and therefore the overall performance of the network will be optimized, and the management also will be simplified, because if sometimes some host is gone wrong, I have to identify in a network which host has a problem. If I have large number of hosts on a single network, it will be difficult to identify. If I know that if I have small networks, and in a small network if I have a very small number of nodes, I can easily identify which node has a problem in which network. So the problem shown by a node on a network, if the number of nodes small, then easily I can locate the problematic node. That is where the management becomes simpler. And I can also span the network in a large geographic area. Therefore, one segment is one network, the other segment is another network. In the same building, in the same organization, if I have multiple buildings, and each building has a different network, because it is carrying a separate segment of the wire. That is what you must understand. So physical media also may be different. That is, one segment may be on fiber optical cable, one segment may be on UTP, one segment may be on other media. So each segment with different media can have a different network ID. That is how the management also becomes useful. And then we are also saving the address space. The other, and the security purpose also, because each network is secure, it will not be penetrated or cannot be. If a large network we have got, then every node is exposed to some problems. So every node will have, in a broadcast message, every node will have a problem. So if I divide in small network, so the security is more important, because a secure network, small network is secure, it cannot affect the other network, all other nodes in the other network. That's why the security also is important. But the most common use of subnetting is to control the network traffic. So like in an Ethernet, what do you see is all nodes in a segment see all packets transmitted by other nodes on the segment. That means a packet sent on an Ethernet is seen by all the nodes in that network. So the security is less. If I big network I divide in small networks of, then only a few number of nodes will look at the packet broadcast. And therefore the performance can be adversely affected under heavy traffic loads. And similarly, a router is used to connect IP networks to minimize the amount of traffic each segment must receive. When the router is sending, is connected to a network segment, so I can have multiple routers or multiple switches used as for the different segment. So I can use multiple switches or multiple routers handling a different segment. Otherwise, for a large segment, I will be using one switching device which may be heavily overloaded. So, if I divide into subnetwork, each subnet can have a switching device, and a switching device is handling a small amount of traffic, so it can handle efficiently. That is what the idea of whole subnetting is. Then how it is done? So, therefore, the important part is subnet masking. So, as I said, the subnet masking allows to determine the network portion, and bits are masked means by as ones, and therefore, if you look at class A, B, that I have explained already. Now, how it is done? The subnet 0 is allows to use first and last subnet in your network design. That means you can use only either the first or the last subnets if you have multiple networks. Look at an example. What does it mean? If you use a class C, mask of 192 provides subnet 64 and 128. That means a class C address is 192 dot something something. Out of that, I use only a 64. The address was 64 and 28 as two subnets. That means you allow to use subnet 0, 64, 120 and 92. What does it mean now? Explain in the next slide. Now look at this. How to create subnets? Number one, how many networks you need, required number of network ID, and each subnet will have one ID, and therefore one for each wide area network connection we will have one network ID. So, you must determine how many networks you need, subnetworks you need, and then how many hosts in a network you need, determine the number of required host IDs per subnet, how many network hosts you need in a subnet, and each host needs an IP address, one for each router interface, and in addition to the host, one host address will be also used with a router interface, because a router may have multiple interfaces. The moment I say multiple interfaces, that means the router has multiple network interface cards, and a network interface card connecting one network, because the router connects multiple networks together. So, if a router connects 10 networks, then it should have 10 network interface cards, and therefore it should have 10 IP addresses as well, because one IP address is of one network, other is another network. So, that is how it is connected. So, based on the above requirement, how many hosts you need, how many network addresses you need, you try to create a subnet, right? And then the question comes, how many subnet does the chosen subnet mask produce, and how many valid hosts per subnet will be available, and what are the valid subnets, and so on and so forth, right? Now, if you look at a simple example here, how many subnets we need? Since we have 128 bits, and then we can use probably 2 subnets, and how many, if you look at this address of 192.168.10.0, then how many hosts per subnet? We will have only 7 host bits, because the 1 bit we are using for 2 subnets. If it is 1, it is representing one subnet, if it is 0, representing other subnet. So, out of 8 bits, because 192.168.10 is my class C address, and last host address is 0, which I am using for subnet. So, therefore, out of these 8 bits, 1 bit is used for subnetting. If it is 0, it is one subnet, if it is 1, it is another subnet, and the remaining 7 bits are for hosts. That means each subnet will have 106 hosts, and that all are not valid hosts, because the 0 and 255 are not used for any host. So, therefore, we will use only 254 in each network. So, we are also reducing some way. So, we will start at 0 and count in blocks of. Now, if you look at this, what are the valid subnet addresses? Out of 256, if you say 128 minus, we have only 128. Remember that all starts at 0, count or blocks or subnets are 0 and 128. So, we will count blocks at the difference of 128. Then what is the broadcast address? If you look at for the first 0 to 127, 127 will be the broadcast address. From 128 to 255, 255 will be the broadcast address. And therefore, we can find out how many valid host addresses will be within a subnet and how many, right? So, if you look at this diagram, there are 2 subnets. One is on the left hand side, other is on the right hand side, and therefore 198.0.0 168, 192.168.0, 10.0 is one subnet, and 192.168.10.128 is other subnet. So this router in the middle, when it receives some packet, it does the network masking, and depending on the network address, whether it has to send it to the left side or the right side, it has to decide based on that. So we will continue with this in the next class, and thank you very much.
With this note, thank you, sir. Thank you so very much for giving us a precious session on IP addressing and subnetting. And dear friends, we would be meeting again soon. Till then, take care. Goodbye. Thank you, sir. Thank you once again.